One important concept to consider in physics is the concept of center of mass. So far, till we start talking about rotation, whenever we study the motion of an object, we ignored the size or the shape of the object. We treated the object like if all the mass was concentrated in one point. That point is usually, even though we didn't specifically discuss it, it's inferred as what we call the center of mass of the object. The definition of the center of mass is the average position of the mass. Okay, now here I have an expression. Remember, position is a vector. It includes, for example, the position along the horizontal, the position along the vertical. If we are talking in 3 dimensions, it's going to have 3 components. How far is it along one direction, the second, and the third direction? Now, remember, position is relative to a reference point. Now, what we see here, the equations that are written, the x position and the y position of the center of mass. And we write it as an average equation. The equation probably does not make sense to you, but let's try to clarify it in terms of an example. For example, if I say I have 4 students who have $1 each, and 5 students who have $2 each. Now, to get the average, I can say I have $5 here and $10 here, so I add them up. $1 plus $1 plus $1 plus $1, that's 4 times, and then add up the 5 $2. So it's going to be 4 plus 10, that's $14, divided by the number of students, that's 4 plus 5, that's going to be 9. So the average amount of money that the students have is going to be 14 over 9, which is approximately $156. Now, another way of calculating that is to say, how many students have $1? 4. So I will say 4 times $1. How many have $2? 5. So I say 5 times $2 over the number of students who have $1 plus the number of students who have $2. So you see here, 4 times 1 is 4, plus 5 times 2, that's 10. That gives us the same thing, $14 over 9. Now this is what this equation is saying. How much of the mass is in x1, m1? How much of the mass is in x2, m2? How much of the mass is in x3, m3, and so on? We just add them up like that. m1 times x1 plus m2 times x2. And then we add up the masses. m1 plus m2 plus m3 and so on. Same thing along the y direction. m1 y1 plus m2 y2 and so on. If it's in 3 dimensions, I'll have to add z of center of mass and do the same thing. Okay, let's try to explain that a little bit more. Let's say I have m1 here, m2 here, m3 here, and let's try to find their center of mass. Now, if this is my reference point, this is my origin, so this is x1 for m1, this is x2 for m2, this is x3 for m3, and the position for my center of mass is going to be m1 times x1 plus m2 times x2 plus m3 times x3 over m1 plus m2 plus m3. That's what that equation illustrates.